So section 10.2 is going to discuss 3x3 systems of equations. What that means is 3 equations and 3 unknowns. Now, before we dive into this too much, let me help you recall some of the stuff we realized in section 10.1 about 2x2 systems of equations. First of all, the solution to your system of equations was what? What does it represent when you have 2 equations and 2 unknowns? What does the solution represent? Ellie?
The intersection point between the 2 lines, if they're different.
Yeah, the point that they both have in common, the point that solves both equations. So in this case, 5, 4. Now, getting a nice, consistent, independent system is not the only thing that can happen when you're looking at a solution to a 2x2 system equations. You could find that the 2 lines could be the same, one right on top of the other. And if that's the case, then what we did was we parameterized the line so that you could talk about any solution. So that's this stuff right here. And finally, there was one other thing that can happen in kind of general terms with your systems of equations. Does anyone remember what that was? Yeah, the 2 lines can be parallel. This is a inconsistent, independent system. There's no solution, so it's inconsistent. They're independent because the lines are different. Now, what happens when we start looking at 3x3 systems of equations is the geometry gets a little bit messier because you're no longer just dealing with 2 lines, you're dealing with the entire plane. So instead of dealing with a couple lines on the whiteboard in front of you, you're dealing with the entire wall. So what I want you to try and do for a second is look around the room, use the floor, the ceiling, the walls, to try and figure out a way that 3 of these could meet at one point.
At the top corner.
Yeah. Our corners. All right. So our corners are where you'd have 3 planes meeting at one point. Now the geometry kind of looks like this, where you have 3 planes that intersect at exactly one point. And that's great. That's what we'd like to see. Now other things can happen as well. You could have 3 planes meet along a line, in which case now there's an infinite number of points of intersection. So that's more of a dependent case. And there's also ways that this can fail. So you could have 3 planes that are parallel, 2 planes that are parallel and one that's askew to those, or 3 planes kind of like this. How many solutions are there for these 3 cases? Is there a point in common to all 3 planes in A, B, or C down below? No. So the geometry's gotten more complex, but the net result is the same. The number of solutions you're going to get is either 1, infinitely many, or 0. So let's see what happens in the 3x3 case. Now to start with, let's start with the easy part, right? Let's do the easy one. Let's do example B here. And I like starting with example B because that's a pretty special case. In fact, if our goal is to find the solution, our solution is no longer just going to be an ordered pair because we have 3 equations and 3 unknowns. Our solution is going to be of the form X, Y, and Z. Sometimes it's called an ordered triple. Sometimes I like to call it a 3-tuple. But whatever you want to call it, your solution is going to be in alphabetical order in terms of your letters, A, B, and C, R, S, and T, X, Y, and Z, whatever they are. But at least we get to start out pretty easily, right? Because we know one of these, right? We know that Z is equal to 3. Great. So if Z equals 3, that kind of helps us out a little bit. Because then we can say, you know what? Let's put that Z equals 3 into this second equation. That's not too bad. Pardon me, negative 3. So we're going to have Y minus negative 3 equals 5. And let's see if we can't solve there. The double negative becomes positive. So it's really Y plus 3 equals 5. So Y equals 2. Wow. That's not too bad. 2 down, 1 to go. We know Z, we know Y. How are we going to find X? Yeah, plug it into the top equation and find X. So in this case, it's going to be x minus 5 times something plus z equals 0. So let's plug in those somethings. And in this case, it's going to be a 2 and a negative 3. So I'll get x minus 10 minus 3 equals 0, or x minus 13 equals 0, x equals 13. Yay! Wow. I'm not sure if you've ever heard of this quote before, Bini Bidi Vici. That's how it's often said. I think it's more like a W pronouncing, Weenie Weedy Weechi, but Bini Bidi Vici. Julius Caesar's said to have come upon a battlefield where he was victorious, and he said, Bini Bidi Vici. I came, I saw, I conquered. So, pretty cool. In any case, we conquered, right? We've got x, y, and z. So our solution that you would write for something like this, in particular into WebAssign, they're probably going to want things as an ordered triple, would be 13, 2, and negative 3. And that's your solution. Nice. Wow, that worked out pretty nice. I mean, if all your 3x3 systems equations were this easy, I think you'd be pretty happy, right? You're like, yeah, just give us about 20 of those on the test the other day, or in 2 days, and we'll be fine. Now, this one worked out pretty nice because it had a particular form to it. And we're going to talk about that form in just a little bit. But you're not always going to be given a problem in this form. So what we're going to do is practice putting a problem in that form so that we can finish solving it. Now, how do we put it into that form? Well, you're going to want to get zeros in the right places. And we're going to practice with this one right here, example A. We're going to take 1 times row 1 and add it to row 2. Now 1 times row 1, it's not going to change row 1. It's still going to be the same. But I'm putting 1 times row 1 just because we're going to be using that idea later. Row 1 is going to be x minus y plus z equals 1, added to negative x plus 4y plus z equals negative 1. What do I get when I add those two together? Pfeiffer?
0.
0,
Plus
okay.
3y plus 2z equals 0.
Nice. So 3y plus 2z equals 0. Great. Let's keep going. This time I'm going to add negative 3 times row 1 to row 3. So, Antonio, maybe you can help me out. What's negative 3 times row 1 going to give me?
Negative 3 times row 1 would be negative 3x minus, or wait,
Plus 3y.
Minus 3z equals 3.
Negative 3. Good. And Ola, I want to add those two together. So when I add negative 3 times row 1 to row 3, oops, I copied the wrong one. It should be, yeah. Yeah, it should be a 3x plus y minus 2z. Oh, boy. Good thing I got some Photoshop here. Equals 2.
Okay, so we're gonna cancel minus 3x with 3x.
Good.
Then it's gonna be 4y plus minus 5z equals negative 1.
Yeah, equals negative 1. Perfect. Perfect. Now, what I've done, or what with your help, is to replace these two terms with a 0. So my new system of equations looks like this. Looks like x minus y plus z equals 1, and then 3y plus 2z equals 0, and finally 4y minus 5z equals negative 1. So, okay, Now that's really just one away from this special form that I have down here. That special form is what's called an upper triangular matrix. Now, it's not something I'm going to quiz you on. I'm not going to say, hey, is this an upper triangular matrix? I'm not going to ask you to define it, but it is something I'll use from time to time because you got zeros here, here, and here. So this is kind of an upper triangular matrix, or it's associated with that. We're going to see that association in just a bit. Yes?
So for the new set, you left the original, like the original number one the same.
Yes, I didn't change that. What I was trying to change is the stuff beneath it. But you're right, I left this one exactly the same. So what changes is what you're adding to. That's the place that gets changed. What you're using to get there to multiply and add, that one doesn't change. Ellie, and then Robert.
In example A, does it have to be that we solve for z equals -3, or can we solve for like 1?
So what I would typically do, it doesn't work out so nice in this case, I'm not going to do it in this case. Well, what I typically do is I want to get a 0 here, here, and here, so it puts it in that form. When I get this, and this term to be zeros, that's when I can do this back substitution. Notice how nicely this unzipped itself, where you knew what z was, then you used z to find y, you used y and z to find x. That worked out pretty nice. And that's going to be our flow of work in this section. Antonio?
Are we also going for that form on that top one? So
We could. It's a little bit more work to finish that one off and get, a 0 here, but you could. Yeah, absolutely. Robert, you had a question as well.
Yeah, I was just going to ask a very similar one. That's why we added the 1 times and the -3 times, because the 1 in the second row gives you a 0 there and then a negative.
Yep, we want to get zeros here and here. Now, to finish us up the right way, we need to get a 0 here. But I want to practice with you something first that is going to help along this process. Now, let me ask you something. Can you conceive it happening that, you multiply and you make a mistake multiplication with your multiplication or addition here? Do you think this step is easy to make a mistake at? With arithmetic? Very. Would it be nice to have something that would help you avoid such mistakes? That's what I gave you earlier before class started, was that row ops. So let me help you out with that row ops. And it's going to take a little bit to see the connection and put things together, but that's where we're headed, is to work with program row ops to try and maybe automate some of this stuff so that you're not going to make arithmetic mistakes. Now, it's not going to change the fact that you need to know what you're doing. It is going to change that you're not going to make arithmetic mistakes. So that's the part that I really like about this. So let's revisit example A in a way that your calculator can deal with things. So what we have is our system of equations, and we're going to need to write that in a way that your calculator can understand. So 3x plus y minus 2z equals 2. And that way that your calculator can understand is something called an augmented matrix. So let's see what an augmented matrix is. Okay, well, what we're going to do is we're going to list just the coefficients here, and that's it. So for instance, the top row would be 1, -1, 1, and 1. What's the next one? What should I write there?
-1, 4, 1, and -1.
Thank you. And then the last one would be 3, 1, -2, and 2. Now, one important thing, if you're going to speak with your calculator about these matters, is to understand the language. And your calculator expects things in this form. The dimensions of this matrix, dimensions, are given in terms of number of rows times columns. So in this case, what would the dimensions of this matrix be? 3 rows, 4 columns. So this is a 3 by 4 matrix. Now it's important that you always remember row then column. So much so that I went out and got a corporate sponsor. So my corporate sponsor is RC Cola. Yay! So, and if you go to the right spot on the campus of Michigan State, allegedly, you can find RC Cola in one of the vending machines. So, all right. It stands for Royal Crown Cola. It's been around since 1905, so yay. But, you know, I joke about that because you need to remember row then column. Now let's put this matrix into our calculator. So open up your calculator. The matrix menu is right above the inverse key. So on the left-hand side, third button down from the second key is your matrix. So to get to the matrix menu, hit the second key, then matrix. Now, I've got a lot of stuff here. Chances are, unless you're borrowing a calculator from me, all these entries are blank. No big deal either way. What you want to do is you want to edit your matrix, so go over to edit first. And then either type the number 1 or press enter. Chances are it'll say 1 by 1 for you. I've already put some matrices in, so it's got this up here for me. But you want to put in the dimensions of the matrix, 3, enter, 4, enter, and then it puts you into your matrix where you can start typing in the actual numbers. 1, -1, 1, 1, -1, and make sure you use the opposite key, not the subtraction key, to enter in these numbers. 4, 1, oops, 1, -1, 3, 1, 3, 1, -2, and 2. All right. Let me pause for a second. Make sure everyone's able to get this matrix into their calculators. Can I have some thumbs up? Thumbs up? All right.
You need to switch the -1 on the top right. Or the 1 to -1. Unless I got it written down.
Okay. All right, so once you're done editing the matrix, you want to exit out of this. So to quit, you hit the second key, then the mode key. That gets you out of it, and now your matrix is stored in matrix A. If you're a little nervous about it, if you're like, gee, I don't know, I'm not sure if that's the right thing there or not, then what you can do is you can kind of print it out to take a look at it. So hit the second key, then the X inverse key again. This time we're not going to edit it, you just want to print it out. So press the enter key twice. And it'll print it out, and you can double check that you've got the right matrix. So if anyone needs to go back, you can go back and re-edit that matrix and change whatever you need to so that it works in the right direction.
What you said exactly do again to get that?
So you can see the keys that I hit right here. On the bottom, it's the second key, the X inverse key, and then press enter twice. And that'll sort of print out your matrix for you so that you can double check that you've got it entered correctly. So if those entries look good, let's move on to the next part. Antonio, good there?
Yeah, good.
Okay, thank you. So the next part, you want to use program row ops. So for me, when I hit the program key, it gives me these two questions. Just press enter and then enter again. A lot of you, once you hit program, you'll be faced with row ops right away. Select that right away. It says, hey, great. Select a matrix you want to use. So you want to use matrix A, so press 1. It says, is this the one you want to use? This is what you're looking at? So yeah. Now let me just kind of walk around a little bit. I'm seeing a couple peculiar looks. I want to make sure that everyone's doing okay here. All right, so I need to put this program on your calculator real quick. See.
What did you get bronze medal in?
Oh, well, thank you for asking. So, last week was Michigan Senior Olympics in hockey.
Oh,
And in the elite division, yours truly, our team won bronze. Good
congrats.
job. Thank you. Thank you. Yeah, that's pretty cool. All right, so let's see. So you want to? Did you not get a deal?
I don't have like the one.
You don't have row ups? All right. Tell you what, just borrow one of mine, and let me yeah. No, just leave me your phone. I don't want to trade calculators because I'm not sure which one I'll get back. Okay. All right, so when you get here, you're going to press the enter key, and it says, well, what do you want to do? And what we're going to do is we're going to kind of redo the same two things we did here. We're going to take row 1 and multiply it by 1 and add it to row 2. And then we're going to take row 1 and multiply it by 3, or -3, and add it to row 3. So that command is right here. Multiply, row, add. That's the one we're going to use the most. So press the number 4 from this menu. What row do you want to multiply? That'd be 1, right? What do we multiply it by? Well, by 1, which is kind of silly, but that's okay. And we're going to add it to row 2. And when I press enter, what we're going to see is my new row 2. So, everyone able to keep up? All right, there's our new row 2. And it matches what we had right here. Let's try that again, except this time we're going to do it with -3 by row 1 and add it to row 3. So, multiply, row, add, that's 4. This time we want to multiply row 1 by what? -3, and add it to row 3, and bam. There you go. So, wow. Now we've got zeros here and here. Now somebody asked me about getting a 0 here. It's a little trickier to get a 0 here because, you know, this isn't a nice number 1 or -1 that I can multiply and, get a 0 there. But you can do it. There's just, some tricks that we want to learn. I don't think I want to do that one for you right here and now. But for now, let's just press the enter key, and you can exit out by hitting 7 twice, and that'll quit the program. You probably should also see a nice little something that's familiar when you quit the program. All right. All right. So let's try that with example C here. See if we can't get comfortable with this program called row ops. So the first thing we're going to have to do is rewrite this equation, and let's see. We're going to have to put in the augmented matrix into our system of equations, and it says eliminate the x term from the second equation. Okay. So there's a couple ways we can do that, but the first thing I need to do is need to work with the augmented matrix, which is going to be 5, 1, 1, 6, -1, 1, 7, 0, 1, -7, -1, -6. So we're going to have to put that into our matrix. We're going to put that in matrix A. So I'm just going to go back and edit that matrix. I'm just going to type right over the stuff that I had there. Second, and then x inverse. you need to go to the edit key before you go to matrix A. That's still going to be a 3 by 4 matrix. 5, 1, 1, 6. And then -1. Then what else? 1, 7, 0, 1, -7. Thank you. -1 and -6. Okay. So there's our matrix. Do you remember how to get out of here? How do you get out of this?
Second row.
Second and then quit. Yep, second quit. If you want to look back at your matrix, press the second key, then the matrix or the X inverse key, then press enter twice. You can take a look back at it and make sure it is what you expect it to be. Once you've edited this, then we can go into program ROPS and do some things there to try and play around a little bit. Now, if you really wanted to just eliminate this X here, then I'd probably do it in 2 steps. On an exam, I'm not going to ask you to write down the matrix every time you make a change to it. What I would do instead is this. I'd ask you to just tell me what you're doing with the rows and row operations. Now, as it stands, it's tough to multiply this by something and cancel out a 1 or a -1. It'd be nice if these were multiples of each other. So what I'm going to do is I'm going to multiply this row by 5. So I'm going to take, my first step is going to be 5 times row 2. So let's open up our program ROPS and do that. So program ROPS, select matrix A. This time I want to multiply a row by something. Which command here do you think here is going to look like it's the right one? To multiply a row, just use command 3. It's going to multiply a row. It says, well, what row do you want to multiply? Well, that'd be row 2. What do you want to multiply it by? 5. So there you go. Now you've multiplied row 2 by 5. And that's going to make it easier to get rid of this X here. Because all I have to do is add row 1 to row 2. And then that's going to get rid of this coefficient. 5 and -5 is going to put a 0 right here. And that's what we wanted. We wanted to get rid of that. So as far as the second step is concerned, you could do 1 times row 1 plus row 2. And it's row 2, it's what you're adding to, that's what's going to get changed. And this is what I'd want to see on an exam. And I don't need to see this matrix as it changes here and there. Just write this stuff. So let's do that. What am I going to choose from my menu here? Which number? 4. Multiply row 1 by 1 and add to row 2. Bingo. There you go. And now that we're done, we'll write the final answer in terms of matrix form. 5, 1, 1, 6, 0, 6, 36, and 6, and 1, -7, -1, and -6. And that's really all that we were asked to do in this one. Oh, don't quit. There we go. Phew. You could also write this out as a matrix. 5x plus y plus z equals 6, and then 6y plus 36z equals 6, and x minus 7y minus z equals -6. So same difference here or here. There's a real lag on this. It's kind of wild. Okay. Are you okay with example C? Yes.
Would you be okay if we just did it out by hand as well?
Oh, yeah, yeah, it's fine to do it all by hand. I mean, some of these, maybe it's more efficient and faster for you to do it by hand. I guess the reason I like the row ops sometimes is because people make mistakes with their arithmetic quite often. And I hate to see you get it wrong because you got a 2z here as opposed to, or maybe you accidentally wrote a negative 2z, that kind of thing. Yes, ma'am.
Could we not do, row 2 plus row 3 to eliminate x?
Yeah, that would work as well. You could easily do row 3 added to row 2. Yeah, that would work nice. Good observation. I mean, my personal preference would have been to interchange row 2 and row 1, and then multiply row 1 by 5 and add it to row 2. So that would have been another way that you could work on this one. So lots of possibilities is what we're saying. Good questions. Anything else? I'm not sure what's going wrong with the video. I don't think the video is going to come out because there's just this huge lag. I mean, look, it should be showing you what I've got going here. It's not. Okay.
Maybe restart it.
Yeah, let's do that.